Welcome. Welcome from the new office. I know today is going to be a little bit of a random one because I'm more the C# near-them guy, whatever. But imagine, you love movies and you love movies so much that you want to host your most favorite, legally purchased ones in a Jellyfin instance, which runs in a Docker container that is hosted on your own private machine in your house. So in case you don't know, Jellyfin is a media server similar to Plex. So imagine you had this. And now the problem is that usually every time you would transcode, like in a situation where you would have your client, which is maybe a phone or something, connecting to a Jellyfin server, and the client would have a smaller display or something, or the internet is not fast enough, or the client does not support the codecs of the movie that you want to watch. So in each of these three cases, the Jellyfin would have to encode, would have to touch the movie file, encode it, and then send the encoded version to your client. So the problem I had so far, which I was not able to solve, and which I was solved right now, which is why I'm making this video, is when you look at this, then you see that when transcoding is running, that the CPU is under heavy load, right? You see like 50% or something, you see it's getting hot, which should not be the case. Usually transcoding should be done by the GPU, your graphics card. So in today's video, we're going to learn how to do exactly that, passing the GPU correctly to the Jellyfin container. We're going to learn about the settings that we need to make and the packages that we need to install and all these things. So yeah, if that is your scenario or your problem or whatever, the video is for you. So as you can see, I already wrote the article, and what we're going to do now is we're going to just walk through the article and I'm going to explain everything to you and show you how it works, and so you can try it for yourself. So first, we're going to have a little overview over the scenario. Okay, so in order to get this, I made a little mermaid diagram, which you're going to open right here, which looks like this. So the elements of my setup are the following. I have a host machine that is running in my apartment, is running on Fedora, and it has multiple containers in it, and one of them is a reverse proxy called Caddy, which is a reverse proxy to your services, and also renews SSL certificates automatically. And behind Caddy, we have the Jellyfin container that is accessing the movie files and serving the movie files, okay? And on top of that, we have any client, like it could be a browser or could be the native Jellyfin app on your TV, on your phone, that does HTTP requests to the host over the Caddy container, and finally to Jellyfin. Like this is the whole scenario. And what we're gonna achieve today is that the GPU that is recognized correctly by the host is actually passed on correctly to Jellyfin, so Jellyfin can use it to do transcoding. So this is what we're going to do today. So the file structure of my system is this. I'll make this a little bigger maybe, a little bit bigger. So we have a Docker Compose file right here, and we have a directory called volume bindings. And this is just the volumes, the files for the containers for Caddy and for Jellyfin. And the Docker Compose file looks something like this. I'm not going to walk through that thing line by line. Just see right here we have the adjust comment. So if you want to use this one, just make sure you adjust the necessary parts to whatever is real on your scenario. Okay. So scroll down. We have a Caddy file, of course. You know that your domain points to the my Jellyfin container, and the important part, just to point it out, like what we're actually focusing on in this video, is the Jellyfin service in the Docker Compose file, the group add property, which is the render group ID to enable the permissions we need, so Jellyfin can actually access the CPU. And the devices thing, as I make the comment right here, makes the host GPU available for the container. Right, so we need to adjust those two things, or make sure those two things are set up correctly, and we're going to do this now, okay? But first, talk about something that you need. So what we're going to do is first, we're going to check if the VAAPI support, VAAPI support is on the host, okay? So this is this thing, what we want to have right here, video acceleration, VAAPI, and we want to know if the host is supporting that. In order to do that, we want to run a VA info. So I'm going to copy this thing right here and go over to my host, and in my host machine, you see I already executed right here. The output looks something like this. And now the important part, when I go back to the tutorial, this is faulty output. And the output is faulty because when you look at this, the VA profiles, then you see that, like those are missing. You see that H264 and HEVC are missing profiles, and we need those. And if those are missing, then Jellyfin cannot do proper video acceleration. It will just fail. So the important part is that we have something like this in the output. In the case we don't have this, I have this little section here, if the machine has no VAAPI support yet. That we have two areas, we have Fedora and we have Ubuntu. And again, my machine is Fedora, so this thing is verified. This thing works on my machine at least. And for Ubuntu, I simply don't know. I asked ChatGPT to generate this code for me. What I know is that those lines work in an Ubuntu Docker container. So at least those lines don't fail in a Docker container. But I'm not sure if it works the same way if the host is running Ubuntu. So please test this one and let me know if this works or not. And yeah, that would be very, very nice. For this video, I'm going to stick to the Fedora part, okay? So first what we need to do is we're going to need to install VA Info if it's not installed already. And along with that, some AMD video drivers. I did this already on my machine, so I'm going to jump to the next point. So as you can read right here, on Fedora 41, and by default, Fedora ships a free Mesa stack which intentionally disables H264 and HEVC. And those are the two we need. So what we're going to do is we're going to enable the alternative repositories in Fedora, like just like these. I mean, you can do this right now. So I already did that, so there's nothing to do. And the next thing we're going to do is we install the free world drivers. And the free world drivers, Mesa V8 drivers, free world, they contain the VAAPI support for those two codecs right here, okay? So again, Ubuntu not tested, please test it for me. So the next thing I'm going to talk about is the render D128 file. And this is something that is created by the Linux kernel when it detects a GPU that supports DRM. Like I put a link what it is. Basically what we want to have is the VAAPI support. If you have a GPU that has VAAPI support, this file will be created and this file will be listing this GPU. And just to explain to you, like I put a little screenshot here, you get here when you go into your Jellyfin, and you go to the burger menu, you go to dashboard, and you go to playback, and you go to transcoding. Then you see it right here, right? So this should be the same for everyone because for some reason, I don't know why, it seems to count up. Like if you have one GPU in your system, the first one is always 128. If you have another GPU in the same system, that meets that standard, the DRM standard, then the next one would be 29. And if you have three CPUs, it's going to be 130 and so on and so forth. But it all starts with render D128. And if you only have one GPU, this should be the same, just the same for you, okay? So this is how you tell Jellyfin what GPU to use. You only have one, this is why this is the value. So to know if you actually have a GPU that has VAAPI support, you can use this line right here. I mean, you can just copy that one. And I go into my host machine. Boom. An important part is we have a render device, and the render device name is render D128, right? So we have this and everything works so far. That is important. So the next thing I'm going to talk about is the group add thing. So in my case, it was 105, and this is the group ID of the render group, and that number can vary from system to system. Just remember that. Like for me, it's 105. For you, it can be something different. And in order to know what is your correct number, I do this. And then the output that you get is this render x 105, and whatever number you have right here, this is then what you put into your Docker Compose file, group add, right? You want to put this right here, the number. So let's go down. We have this part in the Compose file under the Jellyfin service that is called devices, and this passes the GPU to the container, from the host to the container. Now, the group 105 makes sure that the container has the right permissions to access the GPU, okay? So, also drivers have to be installed correctly. Last thing I want to talk about is, if it still doesn't work, meaning you try to play a video file and try to transcode with GPU hardware acceleration and it gives you an error, it breaks, it just doesn't play the file, then what you can try to do is to make sure there is no missing, meaning no missing VAAPI libraries inside the container itself. Like the Jellyfin container that you're running, separate from a host, might be missing those libraries, which is a little bit unlikely, because as far as I'm concerned, the latest Jellyfin image already comes with these packages, but at least in my case, this is what helped me. So what I did is I entered the container with docker exec -u, etc. So this one right here just gives us root privileges because we need to install the packages down here, right? So I copied this one, go into the container, boom, and then what I'm going to do is I do an update and install the packages, right? Boom, boom, boom. Yeah, and then I would just restart the container and try again. Just a little checklist. If you go on your host machine, you did everything correct, and you do an VA info on your host machine, and you get this output, meaning you have these entries right here, right? You have the profiles for H.264 and HEVC on your host machine, and then you go into your container and you have the same thing from your container, right? Boom, boom, boom. Then given you set it up like this, that you have video acceleration enabled right here, and you put in the rendered D128 and you enable everything, then you should be good. And whenever you actually play a movie and then check if you have actual GPU usage, then it should look like this. What I'm using here is a Radeon top instead of B top, right? Your GPU usage should look like that. And then at the same time, your CPU usage should be completely unfazed. Right? It should work. If you're still having problems, please let me know. We find it out together. But I genuinely hope that you don't. I genuinely hope it really just works for you and you're able to pass the GPU from the host machine to the Jellyfin container and you're able to stream just happily, okay? But again, if something doesn't work, please let me know in the comments, and that should be good for now. So that's it. That's how I made GPU acceleration for Jellyfin work in a Docker container. And this might help you also for other things where you need a GPU, like, I don't know, running your own AI models or something like that. Anyways, I know this was a little bit unusual today. Don't worry, there's more coding stuff coming up in the future. I'm just pretty busy recently, but I'm trying to entertain you a little bit here and there with some videos. And that is it for now. I wish you all a lovely week. Bye-bye.